Akathisia. It's one of the most distressing side effects a person can experience from psychiatric medications, and honestly, treating it is a massive challenge in the clinic. So today, we are going to do a deep dive into two major analyses from 2024 to see what the absolute latest evidence says about which treatments actually work and which ones don't.
All right, here's our game plan. First, we'll talk about why akathisia is such a huge clinical problem. Then, we'll get into the nuts and bolts of how a network meta-analysis works. After that, the main event, the results, what was effective, what wasn't. And finally, we'll put it all into context and wrap up with the key take-home messages.
So, first things first. Before we can even talk about treatments, we have to appreciate just how serious and, frankly, how misunderstood this condition really is.
So what is akathisia really? Well, the word itself comes from Greek, meaning inability to sit, and it has two parts. First, there's the subjective feeling, this awful internal sense of restlessness that patients describe as tormenting. Then you have the objective signs, the stuff you can see, like pacing, rocking, or just not being able to keep still. And it's most often a side effect of antipsychotic meds.
Now this is where it gets really striking. This is not some rare, obscure side effect. The prevalence can be as high as 30% in patients on antipsychotics. Think about that for a second. That's nearly 1 out of every 3 people. It's a massive, massive problem.
And this right here, this illustrates one of the biggest clinical traps. Because a person is agitated and restless, it can look a lot like their psychosis is getting worse. So what happens? The antipsychotic dose gets increased, which paradoxically just pours fuel on the fire and makes the akathisia even more severe. It's a vicious cycle that can lead to all sorts of terrible outcomes, like people stopping their meds, treatment failing, or in the worst cases, aggression and even suicidal thoughts.
Okay, so now that we know the stakes, let's dive into the core study we're looking at today. This is the 2024 Network Meta-Analysis by Gambolò and colleagues, and we're going to see how they tackled this really complex problem.
The researchers did a really rigorous systematic review. They started by casting a huge net, finding almost 8,000 potential articles. Then, they went through this incredibly meticulous screening process, filtering it all down until they were left with just the 13 best-controlled trials, which included a total of 446 patients. This whole process is designed to make sure the final analysis is built on only the most solid evidence available.
Now, the method they used is called a network meta-analysis, and it's a really powerful tool. It lets you compare a whole bunch of different treatments all at once. If you look at this graph, each circle is a treatment, and the lines between them are direct, head-to-head trials. But here's the magic. This method can also make indirect comparisons. So even if benzodiazepines and beta blockers were never compared directly, we can compare them through their shared link to placebo. It gives us a much bigger picture of how everything stacks up.
All right, this is the part we've all been waiting for. After all that work, what did the data actually show? Which treatments made a real statistically significant difference in reducing akathisia?
This forest plot gives us a great visual summary of the results. That vertical line right down the middle, at 0, that's placebo. For a drug to be considered effective, its entire confidence interval, that's the little horizontal line, has to be completely to the left of the center line. And as you can see, 3 drug classes clearly made the cut. First up, benzodiazepines. They showed the biggest effect by far. That SMD, or standardized mean difference, of negative 1.42, that's considered a large effect size in statistics. In fact, based on the study's ranking system, benzodiazepines came out on top as the most effective treatment overall.
Next on the list were beta blockers. They also showed a very strong and statistically significant effect. Their SMD was negative 1.02, which is also a large effect size. And you can see that the p-value is very low, telling us this result is unlikely to be due to chance.
And a third effective class was the noradrenergic and specific serotonergic antidepressants, or NSAs. You probably know these as drugs like mirtazapine. They also demonstrated a clear, significant benefit, with an SMD of negative 0.97 and an extremely low p-value, which gives us a lot of confidence in this particular finding.
But you know, knowing what works is only half the story. It's just as crucial to know what doesn't work. And this analysis identified several commonly used drugs that, well, didn't seem to beat placebo.
This table lays it all out pretty clearly. What's really notable here are anticholinergics and antihistamines. These get used all the time in clinical practice to manage akathisia. But according to this analysis, they failed to show a statistically significant effect. Their p-values were all above that 0.05 cutoff, which means we can't be sure their effect was anything more than random chance.
Okay, so we have these results, but, and this is a really big but, no single study tells the whole story. It's so important to put these findings into a broader context and talk about the limitations.
And to their credit, the authors of the Gambolò paper are very transparent about this. They point out that a lot of the trials they included were really small. And that's a problem because small studies can have a lot of statistical noise, which creates uncertainty. They're also more prone to something called publication bias, which is the tendency for only positive studies to get published.
And this isn't just them being overly cautious. This concern was echoed in a huge way by another major network meta-analysis that came out in 2024, this one by Furukawa and his team. They looked at the same question, and their conclusion was, well, pretty stark. They said that overall, their confidence in the entire evidence base for akathisia treatments is low to very low.
So when you put these two giant studies side by side, you see some interesting things. There's definitely overlap. Both point to beta blockers as a good option. But the key difference is in the level of confidence. Where Gambolò's team found a significant effect for benzodiazepines, Furukawa's team rated the confidence in that evidence as very low. So it's not just about the numbers, it's about how much we can trust them, and that's a call for some serious clinical caution. So, after wading through all this complex and sometimes conflicting data, what's the bottom line? What are the essential things that clinicians and patients really need to walk away with?
Let's break it down into 4 crucial points. 1. The Gambolò analysis points to 3 promising drug classes: benzodiazepines, beta blockers, and NSAIDs. 2. A lot of commonly used agents, like anticholinergics, just didn't have the statistical support here. 3. And this might be the most important point of all, the entire evidence base for these treatments is pretty shaky because it's built on small trials. That's why confidence is rated so low. And that leads to point 4. We desperately need bigger, better, more definitive clinical trials to get some real answers.
And this all leaves us with one final critical question that really gets to the heart of the clinical dilemma. We have some signals that a few drugs might work, but with low to very low confidence in that evidence, how do we as clinicians balance those uncertain benefits against the very certain risks and side effects of these medications? That remains the crucial question we have to grapple with for every single patient dealing with this awful condition.